In this video, we're going to talk about graphing an inequality. Now, graphing an inequality is very similar to graphing a linear equation. The only thing that's different, and there's two things that are really different, is that, remember, for inequality, we have solution sets, not just solutions. Therefore, there are multiple solutions here when we start to solve these. And in order to show that, we're going to show this through some kind of shading. And then there's different types of inequalities, which tells we can include or exclude solutions. And we're going to show that through the type of line we create. So we have to get the equation in slope-intercept form still, but we have to pay attention to our symbols now. We need to make sure we pay attention to our inequality symbol. If it's an equal to, it's going to determine what kind of line I'm going to draw. And if it's equal to, that means I'm doing what we call a solid line. So it means a point can fall on the boundary and be included in the solution set. If it's not equal to, or if it's less than or greater than, you're going to draw a dashed line. That means we have to exclude it from the boundary. And then the shading works where we could go through what we call a test point to check our shades, where you plug into the equation and you make sure it's true or not. But the easier way is to just realize that when you're shading, remember you have a starting point, the Y-intercept. You're either going to shade above the Y-intercept or below the Y-intercept based on the symbol. If it's greater than or equal to, you're shading above the Y-intercept. You want to be above your Y-intercept. If it's less than or equal to, you want to be below your Y-intercept. So let's start off with these right here. Let's graph this inequality. The first thing we need to do is make sure we get it into y equals form. Notice that this equation is written as f of x. F of x is a fancier way, or what we call function notation, of writing the letter y. So this is just y is greater than or equal to negative 1/2 x plus 3. We are already in y-intercept form, slope-intercept form, where your m is equal to negative 1/2 and your b is equal to a positive 3. The other thing I need to realize, I need to look at my symbol, and it's a greater than or equal to symbol. So this greater than or equal, first off, the equal part says that I have a solid line. The greater than says to shade above my y-intercept. So when I plot my point, the first thing I'm going to do is I'm going to plot that 3 first. Slope says to fall by 1, run by 2. Fall by 1, run by 2. Fall by 1, run by 2. And so here's the line that I'm getting. And again, I'm going to go this way as well. Up 1, run by 2. Up 1, run by 2. Up 1, run by 2. And I know that this line has to be a solid line. So I'm going to grab this as a solid line. So that's the first part, solid line graphed. Now, the next part says to shade above. Well, I go to my y-intercept, which is here. If I want to shade above that, the shading is going to take place up here. And I can verify that any point in this region is a solution above. And I start out by taking the y-intercept, which is the point 0.6, which is the point 0.3. And I plug it into this equation. Actually, plug in the point here. So f of x just means y. If I take the point 0.3, then this is saying that 3 is greater than, y is greater than or equal to negative 1/2 times 0 plus 3. Is that a true or false statement? Is 3 greater than or equal to negative 1/2 times 0 is just 0? Is 3 greater than or equal to 3? Yes, that is true. If I pick a point in the region out here, such as the point, let's pick the point 4, 6. This is the point 4, 6. What this is saying is that 6, the y value, is greater than or equal to negative 1/2 times 4 plus 3. Is 6 greater than or equal to negative 1/2, which is negative 1/2 times 4 is a negative 2 plus 3. Is this greater than negative 2 plus 3? Well, is 6 greater than or equal to negative 2 plus 3 is 1? Yes, it is. So that's another true statement. As opposed to if I pick a point down here in this region, such as the point negative 4, 4. Negative 4, negative 4. If I pick a point like negative 4, 4, watch what happens when I test with this equation. Here my y value is -4. Is that greater than or equal to 1/2, -1/2 times -4 plus 3? Is -4 greater than or equal to -1/2 times 4 is a -2 plus 3? Is that greater than or equal to 5? No, it's not. This is false. So that means all of my solutions are sitting up here in this top region. Anything above that. We don't have to test, though, because we can figure it out by looking at just the y-intercept. So look at the next one. 3x minus y is greater than or equal to 1. We have to get it to y equals form first. In order to do that, I need to isolate the y value. So to isolate y, I'm going to subtract 3x on both sides. I want to isolate this y value. So I get this: negative y is greater than negative 3x minus 1. Well, I want this to be a positive. I'm going to divide by -1. Anytime I divide the variable by a negative, though, I need to flip this sign. So that's y is less than -3 over -1. That's 3x. -1 divided by -1 is plus 1. Go back and look at my sign. This says that it is a dashed line because it's not including the boundary. It also says to shade below because we are less than. So when I go to graph this, then I'm going to plot my slope, my intercept first. The y-intercept b is equal to 1. The slope is equal to 3 over 1. Remember, write that slope as a fraction. So plotting the y-intercept b at 1, slope says to go up 3 over 1. Up 3 over 1. Up 3 over 1. Up 3 over 1. I can also go down 3 over 1. Like this. And so I get this, and now I can go and graph this as a dashed line like this. There's the line. The shading says shade below the y-intercept. So I'm going to go below the y-intercept. If I'm going below the y-intercept, where the y value is getting lower or smaller at? Down here. And again, I can test those points to make sure that they're actually correct. Or you can just test the y-intercept real quick. It says the y-intercept here is the point. Remember, our y-intercept was a point 0, 1. So if I test with 0, 1, that's 3 times 0 minus 1. Is that greater than 1? If I do 3 times 0, that's 0. Is -1 greater than 1? Is that true? No, it's not. So because that's not true, this is false. We know that the points have to be below for it to be true.